Hello and welcome. In this video, we will discuss on how to visually represent the relationship between entities. After watching this video, you should be able to explain the symbols used to develop an entity relationship diagram. First, let us understand why do we need an entity relationship diagram? An entity relationship diagram is a visual representation of information system. It helps to define the business processes by organizing data, which can be used as a foundation for a relational database. An entity relationship diagram has three main components: entity, attribute, and relationship. In this video, we shall take college database as an example to explain the entity relationship diagram notations. Consider the information of a college database shown on screen, which needs to be represented through an entity relationship diagram. First, let us see what is an entity. An entity is any singular identifiable and separate object. It refers to individuals, organizations, systems, place, or thing about which data can be stored. Student can be considered as one of the entity in the university database. To represent the entity visually, we use the symbol rectangle. Similar to the student entity, a university database can have many other entities like program, course, department, and many more. After defining the entity, we have to decide on what all information can be stored into it. So we can say that an attribute describes a property of an entity and it is represented using the symbol eclipse. Continuing with our example of university database, a student entity can have student ID, student first name, last name, address, birth date as the attributes. An entity can have any number of attributes. So how will you uniquely identify a record? In this case, you can use the key attribute to uniquely identify a specific row in the database, and it is represented using the symbol eclipse with underlying line. A key attribute is the primary key in a database table. Continuing with our example, a student ID can be considered as a key attribute which is used to retrieve unique records from the student entity. An attribute can have more than one value. To represent this type of attribute, we use multi-valued attribute, and it is represented using the symbol double eclipse. Continuing with our example, a student can have more than one email IDs or phone numbers. Derived attributes are the attributes that do not exist in the physical database, but their values are derived from other attributes present in the database. Derived attribute is represented using the symbol dashed eclipse. Continuing with our example, a student's age can be derived from birth date attribute. An attribute can also be further divided into smaller attributes called as composite attribute, and it is represented using the symbol hierarchical eclipse. Continuing with our example, the address attribute of a student can be divided into smaller attributes as city, state, and zip code. Now that we know what is an entity and an attribute, let us see how we can form a relationship between each other. A relationship describes the relation between entities, and it is represented using the symbol diamond. For example, a student enrolls for a course. Here, enrolls is the relationship between the entity student and course. Here, the line connecting between the entity and the relationship type represents the participation constraint. It specifies whether the existence of an entity depends on another entity to which it is being related through the relationship type. The constraint also specifies the minimum number of relationship instances that each entity can participate in. There are two types of participation constraints: total and partial. The total participation is when each entity in the entity set occurs in at least one relationship in that relationship set. Continuing with our example, consider the relationship attends between student and class. A double line from class to attends relationship type is total, which means that each class must have at least one associated student. The partial participation is when each entity in the entity set may not occur in at least one relationship in that relationship set. A single line from student to attends indicates that the student may not belong to the same class. So the participation of student in the attends relationship type is partial, which means that some or part of the set of student entities are related to some class entity through attends relationship type, but not necessarily all. There is another entity called weak entity, which depends on another entity. Weak entity is represented using double rectangle. Continuing with our example, a class can have any number of sections, which means that the entity section entirely depends on the entity class. Also, the relationship type has that exists here is called identifying relationship, which is represented using the symbol double diamond. An identifying relationship is a relationship between the strong entity and weak entity. In our example, class is the strong entity type and section is the weak entity type. Now let us look at the participation of entity set in detail. The participation of entity set is represented by mapping cardinality ratio. So what is mapping cardinality ratio? Mapping cardinality ratio expresses the number of entities to which another entity can be associated through a relationship. A cardinality ratio exists in four possible ways: 1 to 1, 1 to many, many to 1, many to many. A relationship connectivity is represented by 1, m or n next to the related entity. Let us look at each one of them. In 1-to-1 cardinality ratio, an entity in A is related to at most one entity in B, and an entity in B is related to at most one entity in A. For example, A department is headed by an instructor. In 1-to-many cardinality ratio, an entity in A is related to any number of entities in B, but an entity in B is related to at most one entity in A. For example, A department offers many courses. In many-to-one cardinality ratio, an entity in A is related to at most one entity in B, but an entity in B is related to any number of entities in A. For example, more than one student can enroll for one course. In many-to-many cardinality ratio, an entity A is related to any number of entities in B, but an entity B is related to any number of entities in A. For example, an instructor can take more than one class and a class can be taken by more than one instructor. Incorporating all the symbols, participations and the mapping cardinality ratios, the final entity relationship diagram for college database would appear as shown on screen. Let us do a quick recap of this video. An entity relationship diagram is used to visually represent a database. There are three main components in an entity relationship diagram: entity, attribute, and relationship. Entity is any identifiable object to store data represented by rectangle, and weak entity represented by double rectangle. Attribute describes the property of an entity represented by ellipse. And there are many other attributes to represent the property of an entity, such as key attribute, which is represented by eclipse with an underlying line. Multi-valued attribute represented by double eclipse. Derived attribute represented by dashed eclipse. Composite attribute represented by hierarchical eclipse. Relationship describes the relation between entities represented by diamond. And the identifying relationship type is represented by double diamond. Then we saw the participation of instances in an entity set, where partial participation is represented by a single line and total participation is represented by double line. Then we saw how mapping cardinality ratio can be represented for the number of entities that participate in. That is, 1 to 1, 1 to many, many to 1, many to many. Thank you for watching this video.